item on the agenda is to talk about the Earth-Venus-Earth link budget. This is work that has expanded out in the community. This is an initiative that involves the Deep Space Exploration Society. It involves Dwingelo site, Stockert, Bochum in Germany, and several other sites are also interested. And so what we've been doing for the past couple of weeks, so not very long, but good hard work, is developing a link budget, a complete as possible link budget for Earth, Venus, Earth communications. And the link budget is open source, published, and it's a Python notebook. So it's a Jupyter Lab notebook. And what we endeavor to do is to continue this work through the upcoming inferior conjunction. This is coming up real soon, like really soon, essentially now. And that what we would like to do is to keep working on this and develop communications proposals for the next inferior conjunction, which would be when the Earth and Venus are the closest in their orbits. And that next opportunity is October of 2026. So we're in it for the long haul, and I have some results. So we've gotten more and more confident with the results from our link budget. That's in our repo and in the link budget section. And today, what I'd like to do is like to get some consensus and to kind of present some recommendations and to give some results. So I know that Thomas will join us. Lee is already here, and please interrupt at any point. So what I have is a set of slides and some graphics that will kind of summarize some of the results. Okay, there we go. All right, so what we're going to talk about today, or what I have for you today, is a set of recommendations after some results. Where to find this document is in our GitHub. So our GitHub has nearly 70 repositories. We're Open Research Institute. Under the documents section in engineering under link budget, we have a link, something called link budget modeling.ipynb. So that's a Python notebook. So what we're looking at doing is to taking this and splitting it out into its own repository, because this is a project that will be ongoing. The first thing that I'd like to show is kind of why do we care? And so this is on the left is link budget modeling as if you were at the center of the Earth. So you're just a stationary person orbiting around. Venus is orbiting around. And you can see that the Doppler shift when Venus comes closest to us and passes sort of by us on the inner track, it briefly passes through zero. So the Doppler shift is the lowest when Venus is the closest to us. However, and we also have relative velocity chart, and at the bottom is the Doppler shift rate of change. So when Venus is closest to us, that's when the Doppler rate of change is actually the highest. And so these show that it's coming right up. This is something that's going to be happening in the very near future. Now, when you move to the surface of the Earth, which is the graphs that are on the right, then that gets a little bit more complicated. So first of all, you can only see Venus for roughly half of the day. And here we have the altitude, the third down, it changes, it moves around in the sky. And the Doppler rate of change you can see is also kind of different. Now, these are essentially the same graph, just that one includes the fact that you're zooming around on the surface of the Earth. So you can see kind of like the environment that we're developing a link budget within. And that Doppler rate of change, which is on the bottom, actually is important. That's something that feeds directly into the link budget. So based on the current math in the link budget, the March 2025 inferior conjunction is essentially now. We were asked to get involved roughly a month ago in mid-February. We've done a lot about the link budget in a very short amount of time. And we've done all that we can do to raise awareness about this and reach out develop relationships, and we can make some recommendations. Addressing, to directly to our board for ORI board, I think we should remain involved. We should continue developing and using this link budget and produce candidate transmissions for October 2026 inferior conjunction for any site, any amateur site that's cooperative, that would be a good site to kind of include in this effort. So those are the recommendations that I'm bringing forward today. What's the characteristics of a cooperating site? Well, they need to be able to support open source publications, need to be open to digital signal processing techniques and experimentation, and need to be inclusive of the very broad amateur and citizen science community. So what are we talking about when we look at the link budget? So here's a summary. This is the beginning step into the summary. When you start out looking at the budget, then you get a 1 hertz carrier to noise ratio. So we take the site specific data classes in our link budget, and we can look at any number of sites. Each site has to have its own data class. And then we calculate the link budget for Earth, Venus, Earth communications, and we get a number. And from there, looking specifically at some spreading digital signal processing techniques, then we get a bandwidth expansion, which goes down. So it takes us further away from being able to close the link. And then we are able to use coherent processing or coherent integration, and we go back up. That doesn't quite close the link at that point. So we need to do some non-coherent processing after that. This is what this chart is showing you, is these are digital signal processing techniques that we think we need to do. That's not the whole story, however. So over the past week, we've gotten a lot better picture of the physical challenges of this particular link. So on the left and on the right are some new sort of link budget results. It's essentially the same view as this. We have this bandwidth expansion, and then we get to take advantage of processing gain. There's a big loss in this step, in the processing gain, that's not reflected on this graph, and that is Doppler spread penalty. So because Venus is rotating, the signal is spewed out. It's kind of spread out. This sort of Doppler spread is what we're talking about. And that's an additional penalty. And you can see it in the box that says Doppler in the processing gain section. So when you kind of fight back against the bandwidth expansion part, you're going to have different levels of Doppler penalty. And that puts us underwater. Actually, that takes us kind of right out of the fight for now. So we have a Doppler penalty when we have an integration time that is the maximum. Our integration time for the coherent part of our integration, we run into a limit when it comes to the rate of change of Doppler. And so when we enforce that limit, we get 1.34 seconds. That's as long as we can go before the rate of change of Doppler between us and Venus starts to really kind of erode and beat up on our signal. Okay, so we have a maximum. That's great. And when we calculate this and also include the Doppler penalty, we're way down. And so that's what we get on the left. Okay, so a natural question is, well, let's just ratchet back on the integration time. Let's lower it down to where we don't have to pay Doppler penalty at all. And there is actually a point in time where you get that. And if your integration time is 1 over the Doppler spread in hertz, guess what? Your coherence factor drops below 1 and you don't pay any more Doppler penalty. However, your gain, your processing gain, also falls. And it's pretty much a wash. And this turns out to be not unexpected from the way that we understand physics. So that's where we are today. This was what we had last week, and we were very optimistic that we could actually close the link by doing non-coherent processing of Zadov-Chu sequences over time, and that it would work, that we could do it in a reasonable amount of time. Today, we're looking at an extremely long time. 5 million sequences is quite a while. It's not realistic. Okay, so all of this needs to be reviewed. That's what's going to happen over the next week to make sure that we got this right. We got excellent feedback from Gary and Lee and many others that said, "Hey, you're not handling the Doppler spread penalty correctly." And we took it to heart. We put it back in here, and here's the results that we have. So a separate question is: there a chip rate? Is there a for these sequences? Is there a chip rate that helps you? Can you go even lower? So can we lower our integration time? Can we lower our chip rate? Can either one of these? Can we manipulate them? If we just say, okay, the integration time is going to be fixed, and we're going to put it down low enough to where we avoid the Doppler rate penalty or Doppler spread penalty, can we lower the chip rate further in order to get any more traction? So given that integration time is somewhat of a wash, can we show any effect of varying the chip rate? Well, yes, we can. We can run the numbers. Can we increase the chip rate to make the basic processing gain go back up? No, because the bandwidth expansion puts us further away. But can we lower it? And the answer there is so far no. Okay, so we've put this question back out to the community, and we're going to double check all of this. But so far, not great. The Doppler spread penalty is worse than we thought, and it is preventing us from closing the link with things like Zadov-Chu sequences. So when we talk about recommendations based on the math and the link budget, we know that traditional modes, with the exception of a very loud, very narrow carrier, don't close the link. And we've seen the link close because in 2009, AMSAT DL and at Bockham got a bounce off of Venus. They were able to do this. They were able to send a carrier signal to Venus and then detect it. And this was a very interesting result and published result. That's great. So we could duplicate that, and that's a good achievement, but it's still just duplicating a previous result. If you use coherent integration, like the modes that we're talking about, like Zadov-Chu, this gets you a lot closer. Coherent integrations will need to be followed up by non-coherent integrations to further close the link. But so far, when you integrate, when you include Doppler spread, since it's much larger than we previously calculated, nothing so far closes the link. We're not seeing anything work. The recommendation is that we clearly state that the goal is communications and not just detection, since detection has been done. It was done in 2009, done earlier by various governments. What we need to move towards is not just detection, but communication. And another recommendation is that we think the SIGMF file is the preferred way to package transmission data files. Like if you have a proposal, we think we have an idea that we want to try, that in order to make it easy for various sites to use, that SIGMF is the way to go. Okay, so that's what I've got so far for this week, and I'll turn off the screen, and any questions from anybody or anybody that wants to present some information. Oh, I think Thomas is here. I should probably give you the floor because all of this feeds directly into all the work that we've been doing over the past week. So go ahead, Thomas.
Yes, sorry I'm late. I mixed up daylight savings and time zones and everything today. So I fell right in the middle of your presentation, Michelle. So sorry if I missed parts. The first comment is you were talking about Doppler rate and Doppler spread at the same time. I think you're meaning Doppler spread, right, all the time?
Yeah, the Doppler rate of change only comes in with limiting the length of integration time.
Yeah, but the Doppler rate is something we can very accurately calculate.
Yes, I think you all can, but the feedback that I got was that a lot of sites cannot.
Okay.
So we're trying very hard to characterize that limit. That upper limit is something that applies to a lot of sites that can't accommodate that. But it's a very good point. So if you would like to talk a little bit more about that, going beyond 1.34 seconds and what it gives us.
Yeah, so specifically for the Doppler rate and for the Doppler at the same time, of course, we have tools based on SPICE that can very accurately calculate that, and we completely compensate the whole IQ file for any rate change, at least the part that we know. We've done that on the moon. So we did some experiments last week together with Stockard, where we had 30 seconds of Z2 on the moon. That, of course, gives a lot of Doppler rate during the 30 seconds. If you don't compensate for that, you get a very fuzzy picture. At the moment you compensate, the whole thing becomes extremely sharp. So we have some confidence that we can get rid of, let's say, most of that, at least. But the Doppler spread, of course, is a different story.
Yeah, that's really good news on that limit. So I'd like to keep it in the link budget.
Sure.
It's like a, uh, a a limit, but then I think it'll be up to us to explain that if you can compensate for this, if you can accommodate it, then it goes away.
Oh,
So that'll be just that'll be an action item that we take.
okay. The other thing is that for the Doppler spread, you had a number of 31 hertz that I had as well. And maybe I'm part of the confusion here for that reason, which is purely the rotation of Venus. And my initial thought was, well, because of the conjunction, the only component of the Doppler spread is the rotation of Venus, because we don't have any other speed factors between us. That's actually not true, I learned now. Because we are close together, actually the apparent rotation of Venus is the largest, because Venus is basically passing us on the inside. And because of that, we get to see different sides of Venus. So there is an apparent rotation. At the same time, there is the rotation of Venus itself. And now the funny thing is that because Venus has a retrograde rotation, this is canceling each other. So indeed, the Doppler spread is the lowest at the inferior conjunction. And the good news is it's even lower than 31 hertz. So the maximum spread is even on the order of 20 hertz.
Oh, that's really good.
That's interesting. And by the way, this is all due to Kees Bassa. He wrote the tools to simulate this. Can I share something?
Yes, you should be able to.
Now I need to pull up the picture. So let me show you. First download it. Sorry, I had no time to properly prepare for sharing this. Sure. So what Kees did is write a tool that simply puts a lot of points on Venus and then simulates their delay and their Doppler. And from that, create the delay Doppler graph as predicted. The thing is, how do you check whether what you're doing is correct? And we found a paper from Arecibo that had a whole list of actual measurements in it. So Kees overlaid all these measurements on his simulation to verify what he was doing was correct. And in the first iteration, it was not correct, but now he modified it. And here you see actually the orange bars are actual measurements from the 60s overlaid on his simulation. And now you see that actually on all these dates that we have measurements for, the prediction is actually fairly accurate for that timestamp. So this gives a bit of confidence that this simulation gets you at least close. And of course, then the big question is, how does it look like now? So now I need to share this one. Let's see. That should be this one. So this is for next week, Saturday. And you see on the left the different speeds of Venus compared to us, and the Doppler delay plot that we would expect. But most important, all on the right, this is the cumulative Doppler spread. So basically, the lines I've shown here show you that for 1 hertz of Doppler spread, so that's half a hertz in either direction, you have 50% of the power. that is reflected from Venus. So this is kind of a number we can do something with, because now we get back into understanding how much power we get within a certain spread. Yeah, and then for 2 hertz, it's something like 65% or something like that, and then it follows, it goes higher. But you see that the maximum is even under 20 hertz. I'm not sure yet how exactly we should plug this into all your other calculations, Michelle, but it's definitely useful input for that.
Yeah, that was going to be my next question was where we could plug this in. And the good news is that we are already including like Skyfield into the model. So we already have like a decent library handling things like this. And if we can, and then tell it, here's the rotation, here's the position, then I think Skyfield might be able to produce this maybe. And that you know, another thing is that what we've done all along is kind of like take the worst case. So,
Yep.
and now I think you're giving us a view and an explanation and proof that the worst case uh, is not something that we have to enforce, that we can actually, we have some relief here, that we can, if we put in a better model, that we can really get quite a bit of gain back.
I think so. Maybe we could set a number on the power, say for 80% of the power. We do all our calculations for 80% of the power. And then you have a Doppler spread, which is in the order, I'm just reading it here, something like 4 hertz.
Yeah.
And maybe that's a more direct input to the things you have been doing.
Okay. No, I think that's good news. Yeah, because the what we've done is focused on communications to try to get actual, comms. Uh, and then what we did over the past week is as well is to add in just our radar detector. Just say, okay, well, let's go back to the Bockham experiment and let's just at the highest power we can possibly get, uh, aim a carrier wave at Venus and can you detect it? And that's kind of iffy uh, in and of itself. So, any attempts to do really long Morse code, essentially carrier wave for a while, like you have to make sure that any dit or da is long enough in order for you to be able to detect over time the energy accumulated. So with at least DSES, that's their position is that they're going to attempt to send a call sign really slow. Is it slow enough? It didn't really look like it from it's very marginal. And then one of the digital modes, which I don't think has a chance of being picked up in 2 minutes. So I think that there's other experiments, including some BPSK and some Zadov-Chu sequences. Thomas, do you want to talk about that at all, or run through that?
Yeah, just briefly. So if in Dwingelo we get transmit permission, which is a legal issue because we're in the band with Galileo, so we're secondary users, so we need to get a clearance from the Galileo system. If we can transmit, we only will have 2-hour window. And in that window, I want to send a mix of signals, but also not too much variation. So on the moon, I mean, who cares? We can do this for an hour, so we just transmit everything. But here, we settled on doing a CW for a long time, doing a Zadov-Chu sequence, and doing a BPSK pseudo-random sequence. And then we repeat the same one a few times. So we're not going to have a lot of variation because that also allows us to overlay the different receptions on each other. If that proves to be useful, we don't know. We need to make sure that we send in such a way that we have the most optimal chance of doing something with the data later on. And one of the open questions, as I said on the Slack, was the bandwidth, but I think we got some input on that, and it seems we should be on the lower side of the bandwidth for that. So that's basically currently the plan. And then of course we'll receive and store the data from DSAS as well over time.
Oh, very good. All right. Anything else that we've missed? Oh, let's see. I think we have questions. Go ahead, Evan.
Hi, my name's Evan Williams, Princeton, New Jersey. Um, uh, I received the RF bit banger and assembled it. It works. I'm very pleased with the radio. The audio output's not loud enough for me to hear, although I hear that it's a good signal on 40 megahertz is where I've been running. I'm attempting to build an audio amplifier. I'm not really great at that design, but it's two N 2222 transistors. So I should be able to hear well enough to move on to my next stage, which would be to transmit or attempt to transmit on QRP using the radio. But thank you very much for inviting me into the group. I'm very excited. I have a master's in data science and was interested in tree lattices for a long time.
Oh, very good. Well, welcome. And we'll do all that we can to help you get the most out of the RF bit banger. Um,
Who should I approach with questions?
if you're on Slack, then you can ask the designer directly, Dr. Marks. And if you are not on Slack, then I can help you with that and get you
Oh, okay.
connected up to the right people.
Yeah, you did get me invited to Slack, but I'll continue to attend these meetings when I can.
Hey, thank you.
Thank you.
You bet. All right, Rick, go ahead.
I'd like to share a picture if I can.
Of course. Please go ahead.
That is a live picture of the DSCS site right now. The weather is not always cooperative. Right now we have high winds blowing up the sand, as you can see, very high winds, and red flag fire warnings just down the road from me 2 days ago, 2,500 acres burned. So this is the kind of thing that may or may not get in our way this coming weekend because the sand that's blowing around today has to be shoveled out of the way before Saturday so we can do some work. Now, other comments. One of the things that our group is not very well versed in is precision time and frequency, which is my expertise. And I'll be teaching a course in that in May at Haystack Observatory for the commercial world. But I haven't quite gotten ESES on board yet. And what that means is they borrowed a rubidium from the university, a small, tiny rubidium, so that they could send a reasonably good 10 megahertz up to the feed point where the transverter is. Of course, they did not think about at that time the fact that it doesn't matter unless you also feed it to the radio in the control room. We also need or should have precision time as well as frequency so that if we sent, let's say, very slow CW, that we would know exactly when we sent it. And of course, if we know when we sent it, it doesn't take a whole lot of calculations to figure out when you're going to receive it. And those edges could be helpful later when we're doing post-processing, but we don't have all of that finished because I only made it clear to them that we needed to do something better in terms of our transmit frequency and the time at which bits change a week ago, but they did go out and find a volunteer with a better radio, in this case a K4, that they can feed the 10 megahertz into. I did warn them that that doesn't give you phase lock because none of the radios want to inherit the phase noise of any 10 megahertz source, so that it's really a frequency lock. It's like plus or minus 1 hertz is what it locks to, not the phase of the 10 megahertz. So it's not perfect, but it's better than nothing. So we made that adjustment, I think, has been made. A volunteer is coming Saturday with a better radio that they're going to plug in, and if the levels are correct and everything, you know, everything works out, that will be helpful. There's, let's see what else I had here. Oh, we had a failure, which could be critical, in the preliminary tests this past weekend. It turns out that the isolation of some of the components, the relays and so forth, was not as good as was hoped for, and therefore I think we burned out the front end of our receiver with transmissions at 1500 watts. That not only the FET on the front end of the receiver may have fried, but also apparently there was a 50 ohm resistor that burned up and sent smoke flying in the breeze that people noticed. And I don't know where that one was, but it sounds like it was on a directional coupler or one of the combiners.
Oh, wow.
The load resistor for the unused port kind of thing, which again suggests that the precision of this is not perfect, that there's some leakage of that 1500 watt signal. So I'm not certain. I believe that the whole package went back to Arizona for rebuild, and
Wow.
not 100% clear to me that that will be finished in time for Saturday, but it will be back. We will be transmitting. The only question is, will we be listening for our own signal?
Right. Okay.
Only if these things are repaired.
Right. Well, I mean, and also it's fair to say that, like, you know, this weekend versus next weekend, you know, I think Lee was the one that pointed this out. Like, you got time. Like, you could do it now. You could do it next week. You know, yes, this coming weekend is the very best, but it sounds like you had a very exciting week.
Well, I'm not done.
Oh no. Okay, please keep.
There were
Never a dull moment, right?
well, apparently Alex is concerned about the events that led to these failures. So even though long transmissions did not increase the temperature, according to our sensors, in the module, he is still inclined to keep the transmission duration down to 2 minutes instead of 4, to try to minimize the chances of additional failures. So that is what it is. I'm not sure if he'll change his mind on that, but right now that's what I heard in the latest discussions. And the other thing is scheduling. We were hoping to get Australians on board. They were very interested, but they could not get time on the dish, on their dishes. They're already signed up for other science during the times of mutual visibility of Venus. However, not one but two dishes in Australia will try to make themselves available for the next time we do this, which is about a year and a half.
Yeah. Yeah.
And that year and a half could be very valuable to us to continue these discussions on everything from how do we make the hardware better, how do we improve our what I want to do is apply some of the technology we use in VLBI and VGOS systems as it relates to time and frequency, so that correlators can be used. So we're not just integrating our own signal, we can share all of our received noise and correlate them as well as integrate them. And we've got a year and a half to figure that out. And I'm going to take as much information as I can with me on May 3rd. I have a scheduled meeting now with the director of the Haystack Observatory, not just the one dish, but the whole site. He and I went to college together, so we're old friends. And he said, I'll be in town on the 6th. So that's right in the middle of my week up there.
So do you
And
think that they would be willing to be a receiver site for
I don't know what they would be willing to do, but
That
I
kind
want
of-
to talk to them about what we're trying to do.
Is that what you're going to try to find out?
Well, hell, they could be a transmitter too.
Yeah, yeah. But like,
But,
is that what you're trying to find out? Is if the
yeah, well, you see, if you go to the MIT Haystack website and dig far enough, you'll see that they have educational outreach programs that they have done. And I'd like them to consider participating.
Okay.
Because if Haystack participates, Haystack is not so much a place as a center of thought. Haystack, when I go up there, it's Cokie Park, it's Haystack, it's sites all over the world. And I'll tell you, about 40 to 50% of all the technicians, engineers, and scientists who participate in that international community are ham radio operators. So they understand the concepts of what we're trying to do. And so I'd like to try to involve them.
Okay. Oh, that
Maybe
sounds good.
even
You said
get
that was
their-
going to be in early May, that you're going to have these conversations.
I'm flying there May 3rd. I'm spending Sunday, May 4th at Westford Telescope. And then May 5th, Monday through Thursday is the courses.
Okay. No, it sounds like it sounds good. I think these conversations are really potentially very productive.
You never know.
You never know. I asked on Slack if anybody had talked to the Allen Telescope Array, because I'm on their Slack and have gone to a couple of hackfests at ATA, and it was good experience, and I know what they are capable of. It seems like possibly you have to get somebody that's excited about it, that's actually there, that has an insider, right? It's the same sort of approach that you use with schools. If you want to do some sort of activity with a school and help students, then you absolutely have to have somebody on the inside that's a champion for your activity. So I'm hoping that maybe somebody's already talked to ATA or included them in any way. If not, then I can probably start talking to the people that I know through Breakthrough Listen or some of the other projects.
Well, what I do know is when this idea was put forth at DSES, which is a very small organization, there were 2 or 3 people interested. And so I was interested enough to write a proposal. We got some money, and now we have people in Europe and people, an ever expanding group of people and organizations around here. And now we have dozens of people interested and contributing in ways that I could not have even envisioned at the time. My suggestion is we keep trying to expand.
Okay, that's I'll take that. I'll take that as good advice.
Because one thing I know for sure is that no matter what happens this weekend and the following weekends or for the next few weeks, we have succeeded far beyond my expectations in knowledge and understanding and educational expansion. And I have learned so much from everyone else.
Yeah, that's the kind of
that
the
is
magic of it all, right?
that is a success beyond my wildest dreams. Of course, there are those who actually want to hear the signal come back. Oh, that was another thing. That Bochum experiment that succeeded some time ago. First of all, they used like 4 times as much power and had a slightly bigger dish, but that's beside the point. I believe they had an anomaly that they only got the signals coming back when they were approaching what should have been the best position, and nothing as it was going away.
Oh,
And I don't know if that's ever been explained.
that's interesting.
I'm not sure about that. I got to go back and read the paper. But there was mentioned in one of the meetings. I don't know if that's 100% correct.
I think it is. And now we have a good simulation. It might be a very simple thing to actually verify if the Doppler spread is lower on the approach.
Maybe. Maybe that's the reason. They didn't explain the reason. I don't think they knew the reason.
No, it could be a lot of things indeed. And also I mean, this was such a long time ago that it makes it an even bigger achievement, but also their instrumentation was quite poor compared to what we can do these days.
Yes.
It'd be really great, I think, if DSES, if they're able to transmit, they could transmit. I know it seems repetitive, but to transmit something that we know works, like as narrow a carrier as possible for as long as possible, given, and just record the living daylights out of it, because yes, it's a smaller dish and yes, it's a smaller transmitter. Digging that out of the recording is an achievement and would be a very, very good piece of information. Trying to send a CW call sign, just key down, man. Just
Well,
just keep it on as long as possible. Like that's what you should be doing.
Well, we have to send the call sign by law, but we can send it at 30 words a minute and then get back.
Yes, please do. Do not make the
Thomas,
entire transmission the call sign. I tried to very gently kind of suggest that you're going to have it on, that. So
that's why I mentioned the 2 minutes versus 4 minutes. It won't be as long as I would like. Thomas, you mentioned recording IQ data.
Yes.
And I don't think our team has quite figured out how to do that. And I've got a few days. Can you fill me in? What are you using to collect IQ data?
Yes, but that might be a lot to achieve in a few days. So we have written our complete own system of capturing IQ and saving it in SIGMF. So I'm not sure if, given the few days that are left, this is the best approach. So maybe you better get one of the more established programs that can save IQ, like setdump or SDR++ or something like that. And just record and save. And as you have just explained yourself, get good timing with it. The trick I've done with all the moon bounces is also record your transmissions, because then you can always go back into your IQ captures and see exactly what time you were transmitting, because otherwise you will lose the notes and it becomes hard to keep track.
Yes, I think we're going to be transmitting now with the K4, which will also get the same 10 megahertz, not the same phase, but at least same frequency from that little rubidium, and that's helpful. But on receive, I don't think K4 is going to be very helpful. So I don't know what they're planning. I think they're going to use a splitter and record on one of the SDR modules. So the other day, one of our members needed help with something unrelated to this, another experiment that's going on at the site, and he was having trouble with dynamic range and all this stuff. And so I have a Pelican case, like a briefcase, filled with all of my different SDRs and things. So I got them all out, and from the B210 Edis research box all the way down to air spies and things. And I tested every one of them. And I was surprised at what the winner was. It wasn't the B210 at $3,000. It was the more expensive of the cheap SDRs. I think it was an SDR Duo was the winner.
Well, it depends on what you do with it.
Well, it didn't have the
if I can give you
bandwidth
one advice,
capability, but
use the
we're not
B210.
looking for bandwidth capability here. We're looking for narrowband anyway.
Yeah, and I mean we've done interferometry with B210s. So if you have a chance, hook up the B210 and record IQ with it. It doesn't get better.
Yeah, I strongly
seriously.
agree. The B210 is going to blow everything else out of the water. I'm not sure how to explain the results that you've got, but overall, the B210 is an absolute workhorse and outstrips everything else. Just hook it up, record everything, and then deal with it later.
Yeah,
Yeah,
I
that
may
makes a lot
do
of
that.
sense.
I may
Yeah.
do that.
Yeah.
Because
And if you just hook it up to the 10 megahertz and you give it the PPS from one of your GPS receivers, you have excellent timing. And it has all kinds of offsets, but we know the offsets. That's fine. And I do the same thing with Stockard. We both have a B210. So if we have two recordings, they might be both off, but they will always be to the sample exactly the same off. And that helps a lot.
Yeah.
yes, okay. I'll consider doing that. Yeah.
And I think even
I'm glad we talked about that.
the Atlas driver even comes with sample software on Linux, something called RX samples or whatever.
Yeah.
That in itself is already perfect. It has everything you basically need. It will save it as raw IQ, and all the conversions we'll figure out later.
All you need is enough disk space.
That should be fine. Yeah, but yeah.
Okay.
Well, I had over here, my wife's laptop is on one side of me and its battery exploded. And so she's getting my laptop, and I just bought a new one, and it has 8 terabytes of solid state hard drive in it, and 128 gigabytes of RAM, and I forgot how many cores it has. 9. It's an M4 design. It's like when I was just a little bit younger, this was something you saw in the movies. And now I can get it in a laptop. It's like a supercomputer I can carry around with me.
Yeah, you should be okay. Just, IQ fills up disk space.
Oh, it does.
So just make sure that you've got enough for the recording and you're fine. We're over time, but I'd like to give Lee a chance to weigh in because his feedback and his work this past week has been quite good. I think he had an independent a set of calculations that he submitted, and so Lee, you have the floor. Anything you want to talk about? No, still nothing. No audio from Lee yet. But we can also meet later and and I can get all of your feedback, or if you want to write anything more down. But I think that the feedback and all the calculations that you did were very well received by DSES. So Lee presented some sort of independent calculations on very narrowband attempts and showed pretty clearly kind of the challenge in a document. So if you want to, if it's okay with folks, I can share that and spread it around if that's okay with you. So I'll touch base with you later to make sure that that's all right, because I think that brings a lot to the conversation. And also, thank you very much for the previous feedback on the link budget. I think we're working through the feedback from you and Gary and many others, and our goal is to make a complete link budget for Earth, Venus, Earth, and at various sites, like to have a separate data class for each physical site. And what we'll probably do is have it pull out the things that are physically true, Boltzmann's constant, speed of light, distance to Venus, those sorts of things. Those will be a separate data class. So I have a data class for the target, data class for the site. That's probably the next evolution in making this a really flexible link budget, so that you can put in DSS. You could say, okay, let's look at DSES. Okay, let's look at Dwingelo. Let's look at whoever else, and then be able to change those things at the very top of the document and where it's useful for everybody. And then the sort of the machinery of the various link budgets and the worksheets and the calculations. For example, like system temperature, or the things that we're talking about for Doppler spread, which may be dependent on the orbit, part of the orbit that you're in. That's new. That's very useful, and the fact that it's better is super good news, because over the past week we've really come to appreciate that the damage from Doppler spread is much worse than what we originally thought. So the penalty that we pay for Doppler spread, kind of large, kind of a big deal. So any sort of variation in that, we'd like to capture in the model. So we'll just keep working on it over the next for the foreseeable future. So we have opportunity in October 2026, and we want to be part of that and keep helping and improve the model and also explain it. So the talk part, the top part of the each cell in the Jupyter Lab notebook will have an explanation, a markdown that walks through it, and we'd like this to be as accessible as possible. It's already pushing 100 pages long when you print it out as a PDF. So in the end, if it's a book, well, it's a book, so we'll just keep plugging away and make it understandable and useful. So all of the feedback that we've gotten is deeply appreciated. We're just going to keep putting it out there and keep asking questions and keep comparing it to the results over many decades of work. Okay, so yeah, sorry about that, Lee. Yeah, I'm not hearing you. Okay, I'm glad. Thank you, Lee. I'm very glad that we covered the issues you were concerned about. We really, really appreciate your bringing them up, and I really like the write-up that you did for DSES. That was great. So if it's okay with you, if it's okay with you to share it, then I'd like to go ahead and spread it around. All right.
Yeah, I would be very interested to read as well, of course.
Yeah, no, it was good stuff. We want to involve folks and get as broad feedback as possible and include everyone, and to make sure that that we get as broad set of feedback as possible. That's the only way this is going to be really good. So, okay, any last comments or questions before we close? And I'd like to thank everybody for putting up with us going over time today, and we'll publish everything and keep working on it. So I'm going to pause briefly. Anybody have any last minute comments or anything they want to add? All right. All right. We'll be here next week, and we'll just keep plugging away. I think that by next week we might be really, really close to the actual event. So I know folks might be busy. But
next week we will have a successful Venus detection.
Okay, good. Yeah,
yes.
It'll be after, right? It'll be.
Yeah, it is.
Okay, good. So yeah, next week will be kind of a big deal. So if folks have time to come and talk at this time slot, that would be so awesome. We will be super happy to hear about it and to spread the word, help spread the word. And then we'll just keep plugging away. You also should have some pretty good results for Opulent Voice next week as well. So very much looking forward to connecting up with everybody next week. Thank you so much for your time. Time, once you spend it, you can't get it back. That means it's priceless. So it's deeply appreciated. All right, everybody. We'll see you soon.
Thank you.
Bet.
See you later.